Recording is rolling. It's Friday, February 27. We're continuing our review for SAT. You guys know the location information on Google Classroom. I've been posting all these review videos there. You have 70 minutes to complete 54 questions. It's actually over 2 modules, so this is collectively for 2 modules. Guys, what is due in 12 days? Alex, 70% final. Yeah, which some students got, and is working on that. Right, so yesterday, the last one we did was the standard deviation question. Right, so we're picking up from there. On to number 18. Okay, you guys got 18. Ooh, we got this funny looking function here. Guys, what shape is that? If you graph that, what shape would that be? Parabola. Yeah, I got a t squared, I got a t, and I got a constant. That's definitely a parabola of some kind. We got predicted body mass in kilograms after t days for a wildlife reserve. Okay, where time only goes up to 390 days. I think it's days, right? Yeah. Which of the following is the best interpretation of m of 330 is approximately equal to 362 in this context? Guys, when they say m of 330, they're talking about 330 what? Days. So day 330. And
is crow's button.
Okay. Guys, how about this number 362? What does that refer to? 362 what?
Oh, the mass.
Yeah, the mass in kilograms. That's the mass in kilograms. So this would be after 330 days, the predicted mass should be 362 kilograms. All right, let's see. I could let's find a key here. This is mod 2, number 18. Okay, my key is saying it's B. Let me see. The predicted body mass is 362 kilograms after 330 days. Yeah, that's exactly what we just said. It's B. So you guys got 18 is B? 18 is B. Number 19. Triangle XYZ is similar to RST. So X, Y, and Z correspond to RS and T respectively. I've always seen it spelled out that way. Angle Z is 20 degrees. And this side length, XY, is double that of RS. What's the measure of angle T? Okay. Now you might be able to get this just imagining in your mind, but I'm going to go ahead and draw this out anyway. Okay. So we got XY. Okay. XYZ. Okay. There's maybe 2 similar triangles where the sides have ratio of 2 to 1. Okay. We got X, Y. So maybe this is like X, Y, Z. And this could be R, S, T, which corresponds to X, Y, and Z. Is that okay? Similar triangles. And they said XY times 2 is RS. So this length is twice of this length. Okay. Although that is irrelevant to the question they asked, because all they asked about is the angles. They said angle Z is 20 degrees. So the question is, what is angle T? Okay. Now, hopefully maybe you could imagine this in your mind, but if not, you can always draw it out exactly like I did. Okay. And I think the answer pops out now. So guys, what is angle T?
20 degrees.
20 degrees. This is also 20 degrees. That looks like option C, isn't it? You guys think option C? Yeah. Okay, 19. Yeah, 19 is C. 19 is C. 20 degrees. You guys go with that? Number 20. The function f of t. Ooh. Guys, when you see that t in the exponent, here I'm going to write this down on paper. You got f of t. This is number 20. F of t is equal to, we got 60,000. And then times 2 to the power of t on 410. Okay. Guys, when you see this variable in the exponent, that means this equation is what form? Starts with an EX. Exponential. This is an exponential equation. Yeah. Guys, what would you say is the initial population of the bacteria? 60,000. Yeah. Initial population 60,000. Okay. It looks like it's doubling periodically. Maybe every 410 days, do you guys think? Because guys, imagine this. Let's play around with this a little bit. If you plugged in 410 for t, wouldn't this power become 1? 2 to the 1, that's like you're doubling 1 time. So I think every 410 days, the population doubles, right? Isn't that exactly what that means?
Yeah.
All right, let's go back here. T minutes after initial observation. How much time does it take for the population to double? Oh, yeah, that's what they asked. 410. 410. So the answer is 410.
410. What about 4-1?
So that wait, what is the time unit? Minutes. Sorry, the time unit's minutes. I forget what I was saying. But yeah, you had to write 410. Just 410. Okay, so how many minutes? All right, number 21.
Yeah.
The function f of x is defined by this. Here, I'll write this one down too. Let's go. F of x is a to the power x plus b. Okay, guys, isn't this an exponential curve? Just shifted up b units.
Yeah.
All right, that's what that is. Where a is greater than 0. Okay, so positive value for a. That's nice to know. Although we don't know necessarily if it's less than 1, in which case it could be exponential decay. That's also possible. In the xy plane, the graph f of x has a y-intercept at 0, 20, or 0, negative 25 and passes through the point 2, 23. What's the value of a plus b? So I think with these two coordinates, we can figure out what is a and b, and we just got to add them together. Yeah, let's get a new paper on this one. Okay, so you got f of x is a to the x plus b, and they gave us the coordinates 0, comma, negative 25, and also 2, comma, 23. Okay. Now, you don't necessarily have to graph this to get this, but kind of like to throw this on a graph anyway to imagine what this looks like. So x, y, okay. Here could be negative 25. Here could be about 23. We got 0, negative 25 here. And we got 223 here. 1, 2. All right, so this is probably doing something. I bet it's doing something kind of like that, I think. Right, you guys think? Probably exponential. Right. But really to solve this, you just have to plug the points in. So if I plug in 0 for x, that's a to the 0 plus b, I get negative 25. Right. Guys, what is a to the 0?
1.
1. That's 1. So 1 plus b. So guys, what is b equal to? Negative 26. Aha. All right, so we chased down b, we got b. Okay, hold on to that. Okay. Now we got this other coordinate, 223. So if I plug in 2 for x, and well, I know b is negative 26, I may as well just plug that in. I will get 23 as a result. All right, that okay, Jake? Let's solve this. Oh, guys, what's 23 plus 26? Is that 49?
Yeah.
Right. Now they did specify a was a positive number.
7.
A is 7. You know what? Okay. I changed my mind what the curve looks like. Right. If this was between 0 and 1, it might look something else. Right. I changed my mind. Here's B. This curve looks like this. That's what that looks like. Scratch this. There we go. That's better curve. Okay. Exponential growth. Okay. So now we got A and B. A plus B is what? Negative 19. Negative 19. Yeah, I'm looking at the answer key. It says it's negative 19. Hey, you guys got negative 19? Negative 19. Number 22. Y is greater than 13x minus 18. 22. So same thing. I'm going to go ahead and draw a graph. Might be a little overkill. Might not have time to draw every graph on the actual SAT because it's got a time limitation. But it's good to be able to visualize this. So x, y. Okay.
Yeah.
I think down here at negative 18, there's a y-intercept. And then a slope of 13. Guys, that's a really steep slope. And one more little detail. You guys see it says strictly greater than? So I do want to dash this off, actually. Dash, 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 dash. Okay. It says greater than. Guys, which is greater than? Is it above or below the curve? Above. Okay. So it's all this right here. Okay. Guys, would 0, 0 be a solution point? Yeah. Yeah. Let's see that. Is 0 greater than negative 18? Yeah. Okay, so perfect. All right. Which of these tables of values corresponds? So they give you 4 different tables. I guess 3 of these are going to fail at least 1 point, and one of them, all the points work. So I'm going to cheat a little bit. We'll look at my answer key. Okay, my answer key says the answer is D. Did you guys get D? Okay, let's at least check these points though. So 3, comma 26. So if I plug in 3, and then y is 26, is this a true statement? Guys, 3 times 13 is 39. 39 minus 8 is 31. No, that didn't work. What? 13? That failed.
Oh no.
22. What the heck? What did you guys actually write on your answer key as the answer?
D.
You wrote D?
Hey.
Why is this not working? Oh, 18. Whoops, 18. There we go. Okay, no, we're good. 39 minus 18 is less than 26. Okay, we're good. I wrote 8, it was 18. So that's all right. Let's check second point. 5 comma 52. So 52 should be greater than 13 times 5, again, minus 18. Okay, check that out. What's 13 times 5 minus 18? 13. That's 47. 47 is less than 52, so that works. Bing. And this last point, 8, 91. So is 91 greater than 13 times 8 minus 18? 13 times 8 minus 18. All right, so 91 is greater than 86. So bing, that also works. Bing, bing, bing. Yeah. Now, all these other tables, there would be at least one point that fails. Okay? All right, you guys go with that? All right, so yeah, that one might be a little more time consuming. All right, number 23. A certain town has area 4.36 square miles. What's the area in square yards? Where they tell you the conversion, 1 mile is how many yards? Okay. Here, let's draw this out. 23. So we got a town. I know the area of the town is 4.36 square miles. And 1 yard equals, or sorry, other way around. 1 mile equals 1760 yards. There we go. All right, so this could actually kind of be a version of this, couldn't it? Because guys, if you're going from miles to yards, that's a linear relationship. But if you're solving for area, you have to do what to the linear value? Square it. You have to square it. Okay. Or you can solve this with dimensional analysis. Here, I'll do it that way. Let's go area equals 4.36 square miles. Okay, guys, here's a trick I do all the time in my physics class. I learned this in chemistry. Have you guys ever seen this with these railroad tracks I'm drawing? Have you guys ever seen this? Mm-hmm. Yeah? Okay, guys, show of hands. How many guys have done this in maybe chemistry, maybe another class? Who's seen this? Right? About 3 of you guys? Right. So here's a cool trick for converting units. Okay, so we're going to start out with the given values. You got given value right here. Okay. Now my conversion is miles to yards. No, I want to cancel out the miles, right? Yeah. Guys, if I want to cancel it out, should I put miles on top or on bottom? On bottom, so I can cancel out with this on top. Okay. So let's do 1 mile is 1760 yards. Okay. But that's only miles. I need to somehow cancel the square miles. So can I just do that again?
Yeah.
Yeah. So let's do that one more time. 1760 yards. 1 mile. Okay. Now we got miles times miles. Cancels out with square miles. And look at the unit we have left on the board. What's yards times yards? Is that square yards? And the question was how many square yards? So this will be the answer. So 4.36. So in your calculator, just multiply across the top. 4.36 times 1760 squared. Right? Like that. Okay. If there were numbers down here that were not 1 in the denominator, then you could divide by those, but we don't have anything like that. So I'm getting, that is a big number. 13,505,536. Maybe that makes sense because we're talking about square yards. That's a little tiny area. So this would be yards squared. Okay. 13 million. You guys think the answer is 13 million? I think that makes sense.
Yeah. That is just multiplying the 36 times. That would be
yeah, no, that won't quite do it because 4.36 is a square value. 1760 is a linear value. Yeah, so you have to square that. Yeah. So the answer is D. 23 is D. All right, you guys got 23 is D? Okay. All right, 24. A square is inscribed inside a circle. Ooh. I'm going to stop right there and draw that picture. A square is inscribed inside a circle. Let's all get a circle. You guys are drawing a circle on your notes. Okay. and a square inscribed inside. Let's see if I can get this about right. Make this look like a square. I think it's pretty close. Yeah, that's pretty good. Okay, you guys all draw that picture? There's a square inscribed inside a circle. The radius of the circle is 20 root 2 on 2 inches. Well, guys, radius, could that go from the very center to the corner of the square? That would also be the radius, wouldn't it? Okay. So they're telling us that distance, I'll call it r for radius, is 20 root 2 over 2. Yeah, and that's inches with the unit. Okay. Everybody got that? What is the side length in inches of the square? Oh, side length. So then we do some trigonometry here. Because the side length of the square is the same thing as the hypotenuse of this isosceles right triangle. I mean, this is an isosceles right triangle, isn't it?
I just did the Pythagorean.
Yeah, you can do that. Pythagorean theorem. Yeah, yeah. Because this side's also 20 root 2 over 2 inches. Be like that. Yeah, let's try it that way. Can you guys go a squared plus b squared equals c squared?
Why not just simplify it to 10 square root 2?
Huh?
20
Oh.
square root 2 over 2.
Yeah, why did they write it like that? You're right. That is a weird way to write that. You might rewrite this in pink. Yeah, that is 10 root 2, isn't it? Huh. Okay. 10 root 2, 10 root 2, and just okay. So let's go 10 root 2 squared plus 10 root 2 squared equals, well, let's call it c squared. Okay. So this is 100 times 2, is that 200? Plus 200 equals c squared. 400 is c squared. C is the root 400. Which should be 20, shouldn't it? 20? That's inches. Okay. Think that should be the answer? Okay. Oh. There's another way you could also have done this. Is whenever you have you ever heard 45, 45, 90 triangle? That's another special triangle. And guys, 45, 45, 90. The numbers I just said, does that refer to sides or angles?
Angles.
Angles. Because that's 45 degrees, 90 degrees. Okay. Whenever you have that case.
Oh yeah, 2 square root.
Yeah. Yeah, there's a little shortcut trick you do. If this is some side, here I'll call it z. This hypotenuse is always the square root of 2 times that, the root 2z. Is that true? Okay. So another way you could also have found c, let's use this other way, is you could have said, take this 10 root 2 and multiply that by root 2. What's root 2 times root 2? 2 times 10 is 20. It's the same answer. It's the same answer. Bing. 2 different ways to get in there. We tell you the same thing. Right? Little tricks. So the letter choice is A. So 24 is A. You guys got 24 is A? 24 is A. Oh, yeah. 25. Which expression is equivalent to? Ooh. I think we got to find a common denominator. Actually, this is some stuff we've been doing recently in this class. So 25. Let's figure this out. We got y plus 12 over x minus 8. Now, I'm going to leave a space here so I can get common denominator. And we're saying plus, I got y times x minus 8, all divided by x squared y minus 8xy. Okay. Now, I can definitely factor something out of this denominator. Because what can I factor out of the denominator? A what and a what? X and a y. X and a y. So I'll do that first. So let's do y plus 12 over x minus 8. Okay. Leave a space. And then y, x minus 8. Yeah, I can definitely take a single x and a single y out. And I'm left with an x in the first term, and then minus 8. Like that. Would that be true? All right, now, hey guys, what could I cancel? Can I cancel this y right here? Like that? Okay.
How can we get rid of the first one?
What? These y's?
No, the one above it.
Oh, up here?
Yeah.
Well, I see I have 2 terms in the denominator. They each have a y. So I can factor that y out right here.
Oh, okay.
Okay. And then I also factor out an x. So I have an x left here. And over here I got a minus 8. But I pulled the x and y out. Yeah, so this is this. Right. Now, some of you guys might be tempted to cancel out the x minus 8. I mean, technically you could, but that's not going to be very helpful. Guys, why would it not be helpful to cancel out the x minus 8? Even though you could. Because this guy over here has that in its denominator. We want a common denominator, don't we? Right. So actually, let's just leave that like it is so far. Right. And I'm going to go back over to the first fraction and multiply by what over what. Because remember, to add fractions together, you need a common what? Denominator. And we're really, really close. We just need what in the first one? We need an x. So let's multiply by x over x. Remember the theory of why this works. We're technically multiplying by 1, right? Okay. So we can do that. Okay. While I'm at it, I'm going to go ahead and just distribute this x. Okay, and then make one giant fraction time. So I got an xy on top. I got a plus a 12x on top. And I got plus x minus 8 over here, all on top. Now, these have a common denominator, hence I shoved it into one fraction. I got x minus 8. Is that okay? That's going to look like that so far? Right there, right? Right, now, well, I think there's only one more thing you can kind of do. I can combine the 12x and the x to make 13x. You guys can do that?
Yeah.
I think that's the only other thing. It looks like in their answer to, oh, what did they do? No. Okay. They made this unnecessarily messy. Guys, look at all their answer choices.
Yeah.
They have a bunch of y's in the denominator. All right, well, I don't like they did that, but they did. So let's start over. We have to start over. Okay. We're going to have to not cancel this y right here. So maybe I'll just backtrack a little bit. Okay. Let's just pick up from here. Okay. So if we leave the y there, then we also need a y over here, don't we?
Yeah.
So let's multiply in a y over y. Okay, so we got to do that. Okay. Just to make it look like their answer choices. Okay, but let's still do this distribution. So now I got a whole xy I'm distributing here. So that gives me xy squared plus 12xy. Then over here, let's say I left this y here and I'm going to distribute that. That's plus xy minus 8y. Is that okay? Okay. Now, those are different fractions, but we're going to make it all one fraction because there's still a common denominator. It's just different now. Okay. Do you guys see that both these denominators are x times y times x minus 8?
Yeah.
Okay. But it looks like in their answer, they multiplied everything out. So let's just go ahead and do that. xy times x is x squared y. xy times 8. 8xy for subtracting. Okay, that would be the same denominator for both. Okay. Now what? Well, I can combine these two middle terms. So let's go xy squared plus 13xy minus 8y. And then x squared y minus 8xy. Right. Now that looks a lot more similar to their answer choices. So hopefully there's a choice that looks like that. Okay. Let's see if there is.
C.
It is C. Yeah, it is C. 25 is C. Okay, you guys get that? 25 is C? Okay. Which interestingly is not simplified, which we already talked about, but that's what it is. Okay, you guys got 25 is C?
Yeah.
All right. So maybe that's a trick to know too, is when you're going to maybe take a quick glance at their answer choices and make sure that you're not maybe solving it a little bit different way. Okay, 26. Got a function f defined by the, here, I'll go ahead and write this one down. 26. These last two questions, normally the last two are kind of tough. Let's find out. F of x equals a times 2.2 to the x plus 2.2 to the b. Where a and b are integer constants. Okay, so you guys know a and b are constants. Maybe x is a variable, y is a variable, but a and b are some constants. Okay, and it also says 0 less than a less than b. So they're both positive. So 0 less than a less than b. Okay, so a and b are both positive, and b is the larger value. So we know that. The functions g and h are equivalent to f, where k and m are constants. Okay. Which of the following equations displays the y-coordinate of the y-intercept of y equals f of x in the xy plane as a constant or a coefficient? That's a constant or coefficient. Right. Right. So yeah, I see a G and an H look kind of similar, but yeah, they got a K and an M thrown in there. Right. So represents the y-intercept. Well, what could these basically look like? Let's see what they. Okay. I'll go back and rethink about f of x. Guys, could f of x be a times 2.2 to the x plus a times 2.2 to the b? Could it be like that?
Yeah.
Okay. Okay. And guys, since a and b are constants, is this whole bit over here just some constant value? Okay. That's just some number, isn't it? Isn't that just some number?
Yeah.
Okay. And this other bit here is what shape is this? Is that a parabola? No, that's a what kind of graph? Exponential. Isn't that an exponential type curve? Okay.
Yeah.
You guys know what exponentials look like. So let's get a picture. Because if you can imagine the picture, then I think it's going to be really helpful to answer the question. Okay. Exponentials basically do something like this. Don't they? Right? Right. Especially since 2.2 is greater than 1. It's got to look basically like that. Okay. Right. So the right. Where I dashed off this horizontal asymptote, I think that's what this represents right here. Right? Couldn't that be true? That's that. Right. And the y-intercept is on top of that, which doesn't exactly stand out. Like to find the y-intercept, you have to plug in 0 for x, and you get a plus this bit, a plus this bit. Okay. Now, plus this bit could represent the y-intercept. Okay. Well, okay. They said represents the y-intercept as some constant or coefficient. Okay. Now, I don't think a itself would tell you the y-intercept, so it's not a coefficient. But what about the k or the m? Now, guys, if you do just a to something and then you just do plus m, the plus m just brings you up to here. Couldn't this take the place of like plus m right here? This horizontal asymptote. Guys, is this horizontal asymptote the same thing as the y-intercept? What? Guys, is this point equal to this point, which is different? No, those are different places. Okay. Which tells me that the answer is not the plus m one, so it cannot be that one. Okay. And g of x, well, I don't think that plus k would be the intercept either, because you have to distribute to be ak and then plus another a because x to the 0. Right? I don't think either of those represent the y-intercept as any particular single value. Right? Either one you have to chase down. You have to plug in x equals 0 or like 0 for x, right? And then find it. So the answer should be D. Yeah. I'm looking at the key. The answer is D. Okay, neither one. Yeah. So that one's a little tougher. You have to think kind of deeply on that one. Okay, and last one, 27. Ooh, I'm gonna write down the equation for 27. We got x and then kx minus 56. It's all equal to negative 16. It says, in this given equation, k is an integer constant if the equation has no real solution. What is the least possible value of k? No real solution. Okay. Because if I distribute this x, which I'm about to do, then am I going to have an x squared and an x term and also a constant thrown in the mix? What is this kind of marching toward? Starts with a Q. Quadratic. It's some kind of parabola, quadratic, something like that. So I got kx squared minus 56x. While I'm at it, I may as well just add over the 16, right? Get set equal to 0. Right. Because isn't this set up for the quadratic equation to solve? Is that true? Okay. So let's think about quadratic equation. This is probably a good one to have memorized going into the SAT. It might be handy like it is right now. So if this is A, this is B, and this is C. You got negative B plus or minus square root of B squared minus 4AC, all divided by 2A. Okay. That's not too bad to memorize, is it? You're going to the SAT, may as well know that. Let's see here. So negative 56 is like positive 56 plus or minus root of 56 being squared, that negative cancels anyway, whatever. Minus 4, and then I got a k, and I got a 16. This is all collectively divided by 2a, which is like 2k. Okay, is that okay with you? Sure. Okay. Now that's if we're hunting around for solutions. What about this detail here? They say it has no real solution. Has no real solution. You guys see that?
Yeah.
Okay. Now, if it has no real solution, what happens in this quadratic? Yeah.
Square root is negative.
Exactly. The square root, whatever's under the square root, turns out negative. So actually, we don't even need the whole thing. All we need
The discriminant.
is, yeah, you're right. It's called the discriminant. Yeah. This part I'm circling right here. That's all we need. Right? So let's just pick up from there. Is that okay? Because you take the square root of a negative, get imaginary value. Right. I think you both call them complex. Okay. So let's take negative 56 being squared, which is 56 squared, same thing. Minus 4k 16. Okay. And if that has no real solution, that has to be strictly less than 0. Because if it was equal to 0, there would be one solution. It has to be strictly less than 0. So 56 squared is like 3136. 1636 is 64k has to be strictly less than 0. Okay, so 64k has to be strictly greater than 3136. Divide both sides by 64. I'm getting k has to be strictly greater than 49. Right, guys see that? Is that right? Is there any questions so far about any of the process that I just did? Okay. Okay. No, guys, let me make sure you guys are following. What if k was 49 exactly? If k was 49, you go plug in it. Huh?
You want to point on the x-axis?
Yes. Yeah, right. The vertex of the parabola, if this was like y equals parabola, yeah. So there would be one solution. But we're looking for 0 solutions. And we do want k to be an integer. And the question is, what is the smallest possible integer value of k? So what number did you have to write down?
You would hit 50.
50! 50! Because the answer is 50. They're looking for the smallest possible integer value so that you have no real solutions. 50.
Mr. Griffin?
Yeah.
How did negative 56 turn into positive 3001?
Because it was being squared. If you square a negative, it's still positive.
But Mr. Griffin.
Yeah.
And what's answer for 25?
25 is C.
Yeah.
I thought it was 8. I think it was 8.
25?
Wait, sorry, that was module 1.
Okay.
Module 1, what was 26?